Hello everyone, January 17th. Okay, come back to the evening session. Morning is just too much happening. I did make quite a lot of changes to my Vim setup, so it's easier to use. I would say, at the moment, it's much easier to use. At least I get the well, for one thing, I get the telescope grep, the live grep, to work, because I need to install something called rip grep, and I need to install something called FD, which is a faster version of find. I mean, those tools are amazing. They, like, the live grep allows you to grep the everything, like all the files. You grab the content of all the files in your directory, all of them, at the same time. That blows my mind. It's like if you want to find something, you just type what you want to find, and then it will show you whichever file that contains that content. Amazing. And I was able to also solve the problem of the comment, right? So in the previous few days, we saw that the completion, the autocomplete, is still active while you're in comment. But now I found online a way to disable that, which is, it's good. It's very good. Yeah, so just things like this, gradually we start to really build up the Vim. And I still haven't tried a lot of other features, and I don't know how to handle, let's say, a whole project. How do you get the whole project? I still don't know. And then with the panels, I'm still pretty slow with the panels. So I think pretty soon, maybe another week or two of using it, and I'm actually using it in my work because I have some script to write and stuff. So in a week or two, I feel like it's time to watch other videos about how the more advanced users use it. Yeah. Primogen, he has that harpoon thing. I don't even know what that harpoon thing is. All right, anyway, let's get started with today's stuff. Climbing stairs. Climbing a stair, it takes n steps to reach the top. Each time you can either climb 1 or 2 steps. How many distinct ways can you climb to the top? I think this is the classic DP, right? Because each time you can climb 1 or 2. So you say, okay, if I know the number of ways to climbing stairs from 0 to I-1, now I'm at the ith step. And I want to know how many different ways I can reach the ith step. So that will equal to the number of ways, because each step can climb 1, right? So it'll be I-1, right? However many I-1 number of times, then that will become my times, right? Because if you take, say, 6 different ways to reach I-1 step, and then at I-1 step, you can take 1 more step to the ith step. So you have 6 ways to do the ith step, and then plus the I-2, and then that becomes your answer. And of course, you need for this is, that's Fibonacci number, right? I think that's Fibonacci number. Yeah, this is Fibonacci number, because it's your previous one plus the previous one. So what you need to know is the base case. So n equal to 1. If n equal to 1, that's 1 way, right? Okay, and then n equal to 0 is 0. So you start with 0 and a 1. So n equal to 2. It's actually no. 0, I think, is also 1, because you have no step. So you have 1 way to reach no step, right? So 2, 1 is a 2. You have a 1 step and a 1 step. And then you get 2, right? So yeah, 0 is 1. 0 step, you have 1 way. 1 step, you have 1 way. So for 2 is 1 plus 1 equal to 2, right? And then if it's 3, it's 1 plus 2. And if it's 4, that's going to be 2 plus 3, right? Okay, so now what we need to do is just to write a function that we can compute this. Yeah, that's for 18, because that's for tomorrow. That is for tomorrow. Yeah, I got yeah. So yeah, I'm gonna go 18, right? 2024 01 18. There we go. That's the one. All right. Okie dokie. How do we do this? So we have a PP is 1, right? So PP and P shall equal to 1 and 1. And oh, is this? Okay, I don't think. Yeah, now it's right. And then we say for I in range. I think I shall say if n is equal to 1, I'll return 1. Okay, and then for this in range 2 to n plus 1, right? And then we shall say PP will equal to P, and then P, so that will equal to P, and then P will equal to P plus PP, right? So it will be 1, and then P will become 2, and then at the end we'll return P. That sounds right to me. Okay, let's give this a shot. 3, 4, 5, 6, 7, 8, 9, 10, 45. I mean, it's 45. It could have just pre-compute everything and then take it, right? What's Fibonacci number all the way to 45? Oh yeah, basically, yeah, that's the one I add. This is the one I add. Oh, I should upvote this. Oh, I think I upvoted this already. There we go. That's me upvoting. All right, but this is not what I want. What I want to find is Fibonacci sequence to 45. Fibonacci number and 245. Do they have a list? They have a list all the way to 30. Okay, Fibonacci number. I don't think these are the ones you're looking for. This one, right? As a product of Fibonacci number. I don't think that's the one. Yeah, this article needs more work. The first 300, there we go. The first 300 completely factorized. I don't want factorized. I just want the actual number. Dude, I just want the actual number. List of Fibonacci number. Ugh. I mean, okay, I guess. To 45. Okay, this is 0, 1, right? 2, 3, right? So I should at least copy all the way to 46. All right, look, I'm gonna do this. We're gonna split it. Maybe not the smartest way. We're gonna quit this one. Let's split this way. Not a smart way either. You know what? Let's quit it as well. Yeah, I'm still gonna split. Well, Control W and vertical. I still do this way. Okay, so for this one, I cannot edit because edit will be the same buffer. How do I open a new empty buffer here? That's a good question. That is a good question. Open an empty buffer. Maybe I have a full. Yeah, they all like. Why you all have like vertical wise? Jesus. All right. Neovim open a panel with empty buffer. A new buffer in a split. I think this is the one, right? New. Maybe that's the one. New. Okay. Edit new. Maybe. Let's give it a shot. So I'm gonna turn off this one. Well, I need to first save this one, and let's say edit. But that's okay. That is. But how do I go to the previous one? I don't think you can go to the previous one. Yeah, this is not what we want. Yeah, you quit the whole thing. Right? You don't want to quit the whole thing. I don't want to quit the whole thing. I don't want to quit the whole thing. Okay, let me try something else. How do I open a new buffer without opening in the split? I want to open a split window. A V split. Maybe this is not the right way. I don't want to create it in the current window. I want to open it. Maybe there is a way. Hold on. Swap. Increase max out. Max out, go to split. Oh, how about this? We split it. Okay. Go here. And then new. Oh, wait a second. Wait a second. Alright, how do I do new vertically? New vertical. New vertical split. There we go. Oh, but a new buffer has a vertical split. So vert. Okay, a vert. That's fine. We're just gonna go vert. Doesn't work. Vert doesn't work. SBN. That's the same as. Okay, maybe V split. V split. No, it's the same thing. I want a new buffer, like a new, right? Like a new, but on the other side. Yeah, this is an existing buffer. I want a new buffer. Oh, I have a control WN. I didn't know I have control WN. Control W. I think there are more options, right? Yeah. Control W and have more options. Control W. I can't even see everything. Oh, yes. BS. Wait. What's a backspace? Backspace. Hold on. Wow. What did you do? Control W. Backspace to go up one level. There we go. Indent. Prefix. Oh, backspace to go one up. That's not what we want. That's just. Yeah, I didn't say. I need to make it larger. Right. Oh, it never say N. That is interesting. Break out into a new tab. Okay. Already only one window. But I cannot break out into a new tab? Is that what, it's not what I mean, right? Yeah, I don't think that's what it means. That's fine. Yeah, also a vnew command. But let's see, I don't know it. Because when I do Control WV, I usually don't want to split the current. I always want to create a new one, so I can load something new. So okay, so here says this vnew. If I can put on the right side, that will be even better. Okay, so yeah, this is just the rabbit hole keeps growing. vnew on right side, right? Set split right. Set split right. Oh, there's one to swap, right? There's one to swap. I think it's Control W swap X. Okay, I can swap, but I feel stupid. Right, I feel pretty stupid. Split right. Hold on. Split right. Oh, no. I think it's help. Split right. SPR. Boolean global and on. Split a window or put a new window right off the current one. Okay, maybe I should try this. How do I set this in Lua? See, this is the rabbit hole keeps growing. Split right Lua. Oh, I see a split right. Split right. Option does split right. Got it. Okay, we have everything we need. So right now, what we need to do is I need to quit everything. I think it's this. No, hold on. Control W, and O, close all other window. There we go. I'll quit, and we're gonna go to. So first things first, I need this. We need to remap this. This is a key, right? I think this is just. Oh, is this remap key? hold a second. Config neovim. Actually, I have no idea. So let me take a look. So what we're gonna do is to find. I think it's custom options. I have some custom config. So I have the key map set and neovim.set key. I think set key is to call a function, right? So maybe this is a key set. So key set with ESC will map this with this. Huh? What does this mean? Oh, we'll do this first and then followed by this. And then we'll do this. Okay. All right, let's give this a shot. So what I think is map control V, no, control W V to open a new buffer on the right. Okay, so what I'm going to do is vim.keymap.set. So will be control W I don't even remember this control WH is. Oh. Yeah, what's this control WH? Highlight. That was the highlight. That was a highlight. Actually, I'm not sure. I'm not sure. Control this, control N, and control W. I remember the control this, control N. Oh, wait a second. I think control. I think that line number, like relative line number 9 is for. It's for the split console. I think it's to swap split console, which I don't use that anymore. All right, and remap. This is under what? Under it's normal mode, right? Yeah, I think it's normal mode. Wait, is it normal mode? Yes, it's normal mode. Yes, it is normal mode. Okay. So is it gonna be in a normal mode? We're gonna map control W V, map it to ESC vertical new, right? Vertical new, and then caret return and OPTs options. Okay. Now this is not to the right. This is just to put a new buffer. To open a new buffer. Open a new buffer. That's it. That's basically what it does. Okay. It doesn't do any more than that. And then we need to go options here. vim.opt dot right, something right. Split right. Here we go. Split split right equal to true. All right. Let's take a look. So we come here, go here, Control W V. There we go. That's what we want. Holy crap. Yep, this is exactly what we want. Okay, so upvote. Upvote. Okay. I can actually contribute, you know. I can contribute. Custom. I can do what, this one, right? So this is gonna be YY, right? Let's yank it, and then you can put it here for Lua. Config file using Lua. What's this? Well, honestly, for a few things. First of all, this doesn't exist, and then we can turn this off. And then for here, this is no remap equal to true, right? No remap equal to true. Lua custom what's that? Config no remap equal to true. Yeah, that's the one. Okay, that's that. And this is good. Split it right. For Lua config, it's vim.opt.split right equal to true. That's what I remember. Vim.opt.split right equal to true. Good. This is pretty good. I basically got a color column. Wow. Show line number. That is amazing. That's a good. Wait, where is my line number showing? Oh, the WO dot number. Here is just OPT dot number. Maybe it's OPT. Huh. Whatever. Doesn't matter. Alright, so let's get back to it. The reason we do it is trying to find a funny solution. So we'll go do here. Alright, how are you gonna handle this? What the hell is this? Like this? Oh wow, it is. Okay, so maybe I can say this. Actually not true. I think I'll do this. So will be, I think it's percent %s, right? %s. And then this. Then this. Maybe this. This. Oh. I can't match it. Magic. Very magic. Then we do this. There we go. There we go. That is exactly what we want. And we'll do what do we match this with? But nothing. I think that's good, right? And we go back to top. 1, 1, 2, 3. Yeah, and all we need is to put a. So we need to put a comma at the end. How do I put a comma at the end? Well, I can do again. Oh shoot! Oh shoot! %s towards the end. Okay, I'll swap with this. Yes, that was good. Right, and then at the end I'll do this, and we go to the top. We'll do this. We do this, and we will do G. No, VG. No, VG, and we'll go out. No, go out. Going out. Oh, that's more than 4. Okay, no. Let's go GG, VG. We'll yank it. We come here. We say class solution 2. Def climb stairs, self and int. That's fine. It's the same stuff. Now we say fib shall equal to paste here, right? And then v all the way down. Now we can go 1, 2. I remember it's 2. Okay. And this is 1, 2. Oh, I should have done it together. 1. Yeah. This is a 1. So we go up, up, up. Oh, we need one more. We need one more. So we do one more. All right. So up. Yeah, down. All right. So in the return, fib n. Is that n? Yeah. That is not right. I think it's -1. Okay. Up. And then we go 14k. Yank it. Put it here. Run it. Ooh. I am off by 1. It is n. 0, 1, 2, 3. Yeah, that's a 0. Yeah, my bad. This should be right. Wow, look at that. Look at that. A lot of effort just to get a Fibonacci number in. Alright, so here is the trick that I did. No! I thought I... Wait a second, this is bonkers. Yeah, I see. This is good, but... Oh, okay. I was going to complain, right? So, but here... We do this, okay, that's what we want. Okay, that's okay. I thought it was still wrong, but it's okay. So 70, right? Fibonacci number. Hey, and we're doing 01. Alright, that's it. That was fun. Alright, that was fun. Alright, let's try this one. Ways to express an integer as sum of powers given 2 positive integers and an x. Return the number of ways n can be expressed as the sum of the x power of unique positive integers. In other words, the number of sets of unique integers where n is equal to, okay, since the result can be very large, we're going to mod it. For example, n is 160, x is 3, one way to express this is 235. So n is this, x is this, and everything has to be positive integers. Some sort of DP, that's for sure. Alright, so we need to write n in n1x plus n2x plus nkx, right? And we want to know how many unique sets of integers, and they can be identical, right? They can be identical, it doesn't matter. Like if n equal to 2 and x equal to 5, that's 1 to the 5th plus 1 to the 5th. Alright, we're just gonna verify this. So n equal to 1, n equal to 2, and x equal to 5. Oh! I think it has to be unique. Oh, the number of sets of unique integers, so we cannot do duplicates. Alright, so unique integers. Okay. So all these n's has to be unique. So this is not right. Okay, because n is 300, so I can say, you know, we start with 1. So you can say 1, 2, 3, right, all the way down. So what would you say if I say how much is left, right? Because this x is fine, so basically, yeah, the x is fine. So basically you have 1, 2, 3 all the way down to power to the x, right? And you want to fit these inside this. So it's a knapsack problem. It is a knapsack problem. How do you do a knapsack problem? So you either take it, right, or you don't take it. So it's gonna be a DP, right, with the current value. We can call it, let's call it m. So you have m and you have remaining, right? So given remaining, you either take m, right? You either take m. So the number of ways, right? The number of ways, the result. So either equal to dp. So you take m, right? And then you can move on to the next one. So we're gonna start from m plus 1 going down. So that's gonna be m plus 1. And then remaining minus m to the x power. Wait, hold a second. This you don't take, my bad. This is you don't take. You don't take the current. So you'll take the next one. Or keep going. Or be equal to this. And, or you can take the current. So it'll be plus dp. You take the current. Right, you take the current. Then you go to the next one. Then it'll be remaining minus m to the x power. Wait, is that right? How many different ways have this remaining? We're going from this towards the end. So either I don't take this, or I take it, right? Or I take it. So if I take the current, so I have this left. So it will be like that. Okay? And what's the edge case? Well, whenever, if remaining is smaller than 0, right, then it's not possible. We shall return 0. If remaining is equal to 0, right, we shall return 1, because that's a good case, right? That's one way. That's a good case. Okay, give this a shot by opening LeetCode 7. No. Copy. All right, we need func tools, cache. We need to do this def dp m and remaining. Okay, I'm gonna return int. And we'll say mod is 1, 2, 3, 4, 5, 6, 7, 8, 9. Cache max size is none. Okay. Alright, if rem is smaller than 0, we will return 0, and if remaining is equal to 0, we'll return 1, and we shall return dp m plus 1 remaining plus dp m plus 1 remaining minus m to the power of x. And all of this we need to mod this. Okay, and we will return dp, so we start from 1, and we'll have n remaining. We start from this towards the end, how many different ways? I'm not sure, but it's definitely a knapsack, that's for sure. Oh no. Oh yeah, you cannot keep going with this. You cannot keep going with this. So you at least need to have 1, right? You at least need to take 1. So you don't take at a certain point, you can't take any more, right? So if this or PM is m towards the power of x, so we compute it once. Rem is smaller 0, or remaining is smaller than PM, right? If it's smaller than PM, then it's gonna be this. Otherwise, it would be this good, and this we're gonna do PM, power of m. Does this work? Nope, it does not. Very interesting. Very interesting. I return 0, dude. All right, let's try it again. So n is 10, right? And x is 2, so we start from 1. And then if I don't take 1, so we say 2, or we say 3. Okay, so when we say 3, and I say I'll take, so this will be 9, right? No, it should take 1. Okay, we take 1, and then it should be 9, right? And then there should be, 2 with 9, 3 with 9, right? 3 with 9, and this should be 9. And I can take it, right? I take it, and m become big, and that isn't this become 0? So shouldn't we return 1? Hold on. That's very interesting. Let me go back here. Okay, DJ. Let's try 10 and 2. Supposed to be 1. And then x. Number of ways, n and x. Okay, so what goes wrong? So we start with 1, right? And then we say either we don't take 1, And this is going to just end. It's not going to return anything. But this it says if I take 1, okay, and then I will start with 2 with 9 left, right? And then 2 we don't take anything, so it'll be 3. So this will be 3, 9. So 3, 9. If I take 3, so this will be 0. So it will be actually 4, 0. So rem will be 0, so return 1. So one of them shall return 1. How is this not give me what I want? Huh. Or are we not supposed to do this? Now it should be fine. Hold on, I need to do something about it. So rest will equal to this. Print m remaining in the rest. Alright, don't really like doing this, but need to debug. My bad, I forgot to return. Ugh. 3, 9. Okay. Oh, I see. This one shall go first. This one shall go first. This one shall go first. Okay. And then yep. I think I just got that one wrong. So return this. DD. Okay. Alright, try it again. Oh, actually, I can put the other case in there as well. I think we have a 2, 5 case in there as well. Yep. I think this is essentially a knapsack problem. 2 to the n. I think 2 to the n. Well, that's not really 2 to the n, right? Because you have, it is 2 to the n, because either you can do this or you can do that. But is it 2 to the n? But I cached it. I'm confused. Is this not? All right, n can equal to 300. Let's do 1 and 302. Just make sure this is correct. Yeah, it is correct, right? But what's the runtime on this? I'm saying remaining, that's 300. Oh, because you don't know what this is. This can go, this can go as much as n, right? This can go as much as n because we have a limit on this, which means this cannot be, this to the x power cannot be bigger than this. And the smallest x is 1. So this, maybe we can call it O(n squared). Is O(n squared? Is this a knapsack? No, this is not a knapsack, right? It is similar to knapsack. But what I remember, knapsack is a 2 to the n. Because at each point you can have like two options, right? You either take this, right, or you don't take it. And if you take it, oh, it's not, because a knapsack, I think you can take infinite number of knapsacks. Hold a second. I'm getting confused. Okay, let's submit this first. This feels like a knapsack problem. Let's submit it and see if it's correct. It is correct, so it is, right? It is a knapsack, but I'm confused about what knapsack actually is. Okay, hold on, knapsack. Pack a set of items with given value and sizes into a container with a maximum capacity. So you have two things to consider, right? So you have, and you want a maximum. So this is not the maximum stuff. It's just ask you how many ways you can fit those in, right? How many ways you can fit those in. This also requires a value, right? It also requires a value, which essentially is the number of ways in our case, right? $50 items are packed. Oh, this does not. It's just a solver. But you can get to know this problem a bit better. Right? You can't pack them anymore. If the total exceeds capacity, you cannot pack them anymore. You have a maximum capacity. You don't have to reach. So at each step, I remember you can either can you take it away or put it back, right? A subset of items, so we want to maximize the total. So to solve this problem, like for each one, you start from the first and you say, okay, I take it, and then you say the remainder, right? The remainder, or I don't take it and the remainder. So that's the infinite knapsack, which means you can take as many as, yeah, that's 2 to the n. Okay, infinite. So there's a finite version and an infinite version, I think. So 0, 1. Oh, I forgot what's 0, 1. Give n items where put the items in sum of the maximum. Here we can either put an item completely into the bag or cannot put it at all. Okay, that's a 0, 1, which I think is DP, right? DP that can solve. We can take a look. No, it's 2 to the n. What? Really? 2 to the n? Yeah, maximum of... Wait, what's W? W is the remaining. Weight. What's weight? Okay, these two are useless. All right, these two are useless. These two is just... So yeah, it's profit and n. Right? The profit and n. And then each one we say yeah, if it's this we cannot do, or we'll do this and we'll do this. This one plus, yeah, that makes sense. But why can't we DP this thing? Right? We can DP this thing, right? Yes. N times W. Yes, yes. Okay, that fits my understanding. That fits my understanding. And of course you can do like space optimized, right? It's space optimized. N times W. N times W. Yes, yes, yes. Okay. Okay, so this is what I understand. So that is a knapsack, right? In the same way. Now it's not feel like this is a knapsack problem. And knapsack. Oh, I have this. Watch. Leader, new function. Haha. That was beautiful. Ugh, but I don't have this thing on my copy anymore. Oh no. I only need to copy this one sentence. Okay, this feels like a knapsack problem. Yeah, we don't need any of this. I'm just getting excited that I can show this. No, this not feels like. This is, okay, this is a knapsack problem. Essentially, right? Essentially, we are putting. It's not even not just a knapsack problem. It's a 0-1 knapsack problem. We're putting items from 1 to the x, 2 to the x, to a container of capacity n. That's it. And with DP, the runtime can be on. I call it squared because the number of element cannot be more than the count, no more than n. So I call it on squared. All right, pretty cool problem. Take a look. DP. Yeah, that's what I think too. I don't know. I don't think it's never power. I think it's because of this. Yeah, I think it's because of this. So you don't run like all the way down because you have a limit. Oh, yeah, you have a limit. You do, right? You do have a limit. I'm not sure if that's really convincing. It depends, right? This feels like so you can run a little bit less than on. Right? I think that's what it's trying to say, because you have this power thing. So it depends on x, right? If x is big, yeah, the outer loop you run much less. But call it O and log n is, I don't know. I don't feel like O and log n. All right, so that's that. Good. All right, that'll be it. 1 hour, good timing. Let's move on to the next one tomorrow. All right, I'll see you guys tomorrow. Adios.